Great, so inequalities. So we're going to be dealing with shading and setting areas of solutions and such things. The first part of 1.7 was dealing with linear inequalities. So you're going to solve those just like you did back in Algebra 1, where you're going to get x on one side, numbers on the other. Solve for x. Remember, if you're multiplying and dividing by a negative, you have to flip the inequality around, et cetera, et cetera, et cetera. One of the new topics is going to be this idea of quadratic inequalities. And so when you do this, you're going to set them up just like you would solve a quadratic equation. The first thing that we need to do is we're going to end up moving the 24. So we're going to set this all equal to 0, just like you would with a quadratic equation. So you get x squared plus 14x plus 24 is going to be greater than 0. And then at this point, what you're going to want to do is, again, just like before, you're going to factor this out. Now, this is where things change a little bit. And you're still going to factor it out, but in terms of what we do with the solutions is going to be the different part. So two numbers that multiply out to be 24 and add up to be 14 would be 2 and 12. So you get x plus 2, x plus 12 is greater than or equal to 0. Now, here's where the differences happen. You're going to take each of these factors and you're going to set them equal to 0 to figure out what, I want to say, almost like the problem children are. So the issues that we're going to have that are going to make this true are the border areas are going to end up being x equals negative 2. So that's going to make the first binomial equal to 0. And the other one's going to be x equals negative 12. Now, the answer is not as simple as just saying, okay, well, then the answer is going to be negative 2 and negative 12. This, again, remember, with a linear setup, what ends up happening is that you're going to end up getting a set of a series of solutions that it's actually a range of numbers. So here, you're going to need to draw yourself a line. We're going to make it nice and neat down here. And on this line, you're going to draw some points. And these points up here are going to be the important ones. So we've got one here for negative 12. We have one over here for negative 2. We have another one for 0. And the reason why I'm putting 0 in here is it gets, again, gives a good sense of, almost kind of a grammatical issue. The points that we're going to end up graphing here is we're going to have a point here at, negative 12. And we're going to have a point here at negative 2. As I said, these are kind of like the border points because this is going to separate what parts are shaded and which parts are not shaded. They're open circles because, again, the original inequality has, there's just greater than, it's not greater than or equal to. Now, the part that's different is you're going to have to test points. And some people like to do charts. I actually like doing it on the graph just because it's easier to do visually. So what we're going to do is we're going to test a point somewhere less than negative 12. So I'm going to say let's test equals x equals a negative 15. So at this point, I'm going to plug that back in, ideally into the original equation. So I'm going to test in negative 15 in for x. Apologize for the handwriting. Plus 14 times a negative 15. And is that going to be bigger than a negative 24? Here you get 225. Plus, and that's going to be, what, approximately 200? Yes. Sorry, just doing that off the top of my head. My apologies. So plus a negative 200. Is that bigger than negative 224 or negative 24? And the answer is yes. So that means that this is true. If it is true, just like what you would do on a normal number line, is then you're going to end up shading this side of the inequality where it's true. Okay, so that means that this section over here is part of your solution. We're going to test another point. So over here, we're going to say, okay, let's test x equals negative 10. Fairly round even number. So I'm going to plug in negative 10 squared plus 14 times a negative 10. And is that going to be greater than a negative 24? So you have 100 minus 140, and I think at this point you can see that is not equal to a negative, not greater than negative 24. So since that's not true, actually I'm going to rewrite it this way, my apologies. Oops. So that's going to be, I'm going to ask, is it greater than negative 24? The answer is false. So I'm not going to shade in between those two. And of course, our favorite test point, 0, since it makes the values work out okay. So again, if you ever have a chance to use 0, go ahead and do it because it makes life a lot easier. So then you're going to get 0 squared plus 14 times 0, and that is definitely bigger than a negative 24. So that's going to be a true statement. So then everything over here is going to be shaded since that's part of the solution. Again, as I said in class, this is a lot like when you guys were doing linear inequalities back on Algebra 1, where you'd graph the line, you pick a test point, and if it was true on the same, let's say we picked 0, and that was true, remember then you'd shade on the true side. If it was false, you'd shade on the other. Okay, so same idea. And now the only other thing that we're doing that's definitely new, much like what we were doing with the linear inequalities, is writing this in interval notation. And the name, just as it implies, sets up the intervals where the solution holds. So what you're going to do down here, and the nice thing, and this is the other reason why I like doing it in terms of the number line, because it really does graphically kind of match up. So we're going to take all numbers that are less than 12. So we're going to start, we go down as low as all the way through negative infinity, and we'll go up to, but not including 12. And the same thing over here, we'd also take numbers that start at negative 2 and go all the way to infinity and beyond. Since it will go in either or, we're going to make them the union. And again, as I said, I like this almost better than writing off, okay, well, x is less than or equal to negative 12, or x is greater than, that should be greater than or equal to, greater than. Because the reason why I like it is because the numbers are going in all different directions, where with the interval notation, this matches up very nicely with what's going on here. Okay, negative 12 going all the way down, negative 2 going all the way to the right. So it's visually, it matches up nicely. Couple of reminders. Remember that when you're doing this, parentheses mean that the number that is closest to the parentheses, in this case the negative 12, the numbers go up to, but do not include that negative 12. If it was a hard bracket like this, then that would be including it. Now, given the fact that we're at 7 minutes for this example, and I've talked a lot of the background, I'm going to go ahead and end this one, and then we'll pick up at the next recording with what we do when there's rational expressions as part of your inequality.